Okay, we are gonna solve an exercise on an exponential function. We have the general exponential function here, y equals k a to the x. We have the parameters k and a. Those are the two parameters that we can find in an exponential function. Depending on those two parameters, we have different types of different exponential functions, and they give us the information that this exponential function goes through these 2 points, -1, 6 and 2, 3/4, and we have to find with that information we have to find parameters k and a. So we act as usually. If it goes through point -1, 6, it means that when we replace the x by -1, the y comes up with the value 6. So 6 is the value of the y, k and a to the -1. Okay, so well, a to the -1, we know that is an a on the denominator, so it's 1 over a, or if you prefer, k over a to the -1 sends the a to the denominator. And we are going to move it over here, solve for k, so a comes here multiplying, so we are going to have 6a equals k. So we have one equation relating k and a, but we don't have yet enough information to solve for a and k. We need one more equation, but we have one more point, so we are going to do exactly the same. In this point we have 2 3/4. That means that when the x takes the value 2, the y comes up with the value 3/4. So 3/4 equals k times a to the power of 2, which is square, a squared. And here, well, we don't have much choice here. We can set up the equation as it is. So combining these two equations, we have to solve for k and a. And the easiest way is, as we have here k, we are going to use substitution, so we are going to replace the value of k in this equation by k in the second equation. So we are going to have 3/4 of k is 6a, so 6a times a squared. This k becomes 6a. We have 6a times a squared, so that takes us to 3/4 equals 6a times a squared, that is a cubed. Okay, and now we are gonna solve for a cubed, so the 6 goes to the other side. As it is multiplying the x, it goes dividing, so we have 3 over 6 times 4 is 24 equals a cubed. Okay, good. We can continue here. I'm gonna write the a first. A cubed equals, and now what I'm gonna do is simplify this fraction. So divided by 3 on the top and on the bottom, we have 1 over 8, 1/8. And finally, we can solve for a. If a cubed is 1/8, a would be the cubic root of 1/8. And the cubic root of 1/8 is 1/2. Okay, so we already have a, and if we have a, it's quite easy to find k, because k is just 6 times a, 6 times a, and a is 1/2, so 6 times 1/2 is going to be 3. So we already have k, which is 3, and a, which is 1/2. The base of the exponential function is 1/2. Now, if we remember some of the features of exponential functions, we know that the k, these are the coordinate axes, x and y, and we can make a sketch of the graph of this function. We know that k is the value of the y when x is 0. When x is 0, we make the 0, 1/2 to the 0 to the power of 0 is going to be 1, so we get y equals 3. This becomes 1 and we get y equals 3. So that means that it's going to cut, it's going to hit the y-axis in 3. And now as we can see that the base is less than 1 and the exponent doesn't have a negative sign, that means the function, the exponential function, is a decreasing function. Okay, it is a decreasing function. Remember, the shape of the exponential functions is always something like this. The y-axis, the x-axis is an asymptote. Okay, so that would be how we find the parameters. Okay, and now we are gonna do a similar thing, but in this case it's gonna be in the context of a problem, of a real problem. In this case, we have as well an exponential function, and well, this is the function that rules the process of infection of a virus, something that has been very on fashion lately, unfortunately. And well, we have the information that on day 0, we call day 0 the day where the first the first infected people were found. So on day 0 they found 8 people infected, and the virus is spreading in such a way that 10 days after that, on day 10, we have 8,192 people. Okay, so we want to know the exact form of this exponential function. So we want to know these parameters in order to be able to predict how the virus is going to spread on the future if we don't set up some measures that may hinder the spreading of the virus. So viruses, when they spread, they do it with an exponential rate, at an exponential rate. Okay, so exponential functions are used to study processes of this type that happen that spread very, very fast. So we do as we have done before. On day 0 is going to be 8 people. That means that when we replace the x, well, I have to say that the x, I think it's quite obvious, but I have to say that the x is representing the days, the number of days starting by day 0, and the y is representing the number of people infected. Okay, so for day 0, 8 people. That means that when we replace the x by 0, the y becomes 8. So 8 equals k times a to the 0. And in this case it's even easier than the exercise we did previously, because a to the 0 is 1, so we are going to have only k, so we know that k is 8. So with no calculation at all, we find the first parameter. And we do this the same with the second point that we have. We know in day 10 it's going to be 8,192 people. So just replace 10 by the x, or the x by 10, and then the y becomes 8192. So 8192 equals k. I'm not gonna write k anymore because I know it's 8 already, and ka to the x, and the x is 10. Okay, so now we just move this 8 over here, dividing, so we have 8 to the 10 equals 8192 divided by 8, and finally we can say that a would be the 10th root of 8192 divided by 8. Okay, well, it's not hard to find out with a calculator that this number is 2. The result is 2. So the base of the function is 2. So we already have the function. K, we said, is 8, and the base of the exponential function is 2. Okay, so after that we can predict the number of people infected at any point of the pandemic, considering that the pandemic is going to continue like that. Obviously, it has many other factors, and many other measures can slow down the process, but theoretically, with an infinite number of potential people to be infected, this is what a pandemic, this is how a pandemic would behave. So imagine that they tell us to find out how many people are going to be infected on day 20. So we go and just replace the x by 20 with the parameter we have found, and that's all we have to do. Do the calculations, and any calculator can tell you that there is going to be a humongous number, 8,388,608 people infected. Okay, so as you can see, this process is an example of a very fast increase, and a function that increases very fast. Actually, the term exponential has become the term that we use to imply that a process grows very fast.